Okey, Assalamualaikum warahmatullahi wabarakatuh. Okay, selamat pagi semua. So, pagi ni kita teruskan kelas kita. Okey, kita akan dengar presentation daripada kawan awak. Okey, so sekarang ni baru ada 8 orang. Okey, yang hadir ni tolong update you punya nama dekat ruangan komen Okey, update you punya nama dekat. Okey. So, siapa yang ada boleh update nama dekat ruangan komen. Okey, untuk saya tahu siapa yang ada dan siapa yang tak ada. Okey, so saya teruskan pada presentation daripada grup yang pertama. Okey, sebelum kita start kelas kita, kita boleh baca doa dulu sama-sama. Okey. So, grup yang pertama ni daripada berintangan daripada grup Zarul ya. Grup Zarul. Sekejap.
Assalamualaikum. So today I want to present about chapter 6, carbonic compounds, aldehyde and ketone. So first we take a look at 6.1, structure of carbonic compounds. Learning outcomes. Students should be able to give the general structure formula of aldehyde and ketones. Functional group is carbonyl, C double bond O. So first we take a look at aldehyde. C double bond O must be at the last carbon. Ketone. C double bond O must be in between carbon. R is alkane group, carbon group. 6.2 Nomenclature of carbonyl compounds. Learning outcomes. Students should be able to draw the structure and name the carbonyl compounds according to the IUPAC nomenclature for aldehydes and ketone. So first, aldehyde. Alkane turn into alkyl. Methane turn to methanol. So Al, these two present to Al this. And IUPAC nomenclature and common name for aldehyde compounds. First, we have formaldehyde. IUPAC name of formaldehyde is methanol. And C double bond O here. And another aldehyde compound is acetaldehyde. IUPAC name ethanol and C double bond O was at the last carbon. And then benzaldehyde, phenylmethanol, C double bond O at the last carbon too. We move to example. CHO in the longest chain, C chain must be number 1. CHO in the longest C chain must get lowest number. For example, C double bond O here was at the last C chain and it has to be number 1. So here is number 1. This is 2, this is 3, and this is 4. And this is methyl, and methyl is at carbon number 2. So the name is 2-methyl-butanol. And then we take a look at 2-isopropyl, 2,4-dimethylhexanol. So we need to find the longest chain, and C double bond O must be numbered 1. And we find the longest chain first. This is the longest chain. And C double bond O the C is number 1. And this number 2, 3, 4, 5, and 6. So it was hexanol. Hexanol. because it has 6 carbon, and this is it was at carbon number 2, so it 2-isopropyl. And this is methyl at carbon number 2, and also this at carbon number 4. And the name is 2-isopropyl 2,4-dimethylhexanal. So we move to 2-tritrimethylhexanal. And first we need to find the longest chain. We need to start with C double bond O. So we find it, and this is the longest chain. And C double bond O must be number 1, 2, 3, 4, 5, 6. And this is hexanal. 6 carbon hexanal, and this is methyl, and methyl. So that was methyl. And it was at a carbon number 2 and 3, and the name is 2-tritrimethylhexanal. So we take a look at the aldehyde. CHO attached to a cyclic. As we can see, C double bond O, it was attached to a cyclic here. And name of the ring followed by a carbaldehyde. And so we take a look at CHO attached to a cyclic, and name of the ring followed by carbaldehyde. And it's in CHO attached to a cyclic, and this is CHO, it was attached to a cyclic, and this cyclohexane, and we just put a carbaldehyde at the back. And then we took a look at 4-isopropyl 2-methylcyclopentane carbaldehyde. Carbaldehyde we take from this, and 4-isopropyl is this, and 2-methyl is this is cyclopentane, and is cyclopentane carbaldehyde. This is pentane. This is C double bond O, and we just make it cyclopentane carbaldehyde. So we look at ketone. Alkane turn to alkanone, and propane turn to propanone. And one at the back we took from this ketone, ONE. And we take a look at IUPAC nomenclature and common name for ketone compounds. First, acetone. IUPAC name is propanone. The structure will be C double bond O attached to C and C. Because ketone is C double bond O, must be at between carbon. And then we take a look at acetophenone. IUPAC name is 1-phenylethanone. And this is C double bond O attached to a C and this C. C double bond O must be in between carbon. CHO in the longer C chain must get lowest number, which is 5-methyl-2-hexanone. We need to count the C. 1, 2, 3, 4, 5, 6, and it was hexanone. And the double bond O was at carbon number 2. This is carbon number 1, 2, 3, 4, 5, 6. And this is methyl. Methyl was at carbon number 5, and C double bond O was at carbon number 2, and the name will be 5-methyl-2-hexanones. We take a look at another example. First, we need to find the chain. ketone, C double bond O must be in between carbon. So it need to start from here and down here and go here. And as we can see, this is carbon number 1, 2, 3, 4, 5, and 6. So this is methyl, methyl, and methyl. So it trimethyl. And we look at the carbon, and this 2 is at carbon number 3 and this is carbon number 5, and it become 3,3,5 trimethyl 2-hexanone because double bond O here at carbon number 2. 2 cyclopropyl 4,4-dimethyl hexanone. And we need to find the longest chain because C double bond O here, it need to get the lowest number. We start from here. 1, 2, 3, 4, 5, 6, and it become carbon number 3. This 1, 2, 3, 4, 5, 6, and it was hexanone. And then this is methyl, and this is cyclopropyl. And methyl was at carbon number 4 and cyclopropyl at carbon number 2. That's why the name is 2-cyclopropyl 4,4-dimethyl 3-hexanone. So just that from me. The question will be given in the comment.
Okey. Okey. Hello. Okey dengar. Okey, saya teruskan dengan presentation daripada group yang kedua. Okey. Okey, daripada group Nick Okey, boleh tengok video ni.
So today I would like to present about preparation of carbonyl compound. So this is my group members. Learning outcomes for this topic is at the end of this lesson we should be able to explain the preparation of carbonyl compounds through oxidation of alcohol. Preparation of carbonyl compounds, there is 3 oxidation of alcohol, which is primary alcohol, secondary alcohol, and tertiary alcohol. Primary alcohol will produce aldehyde, secondary alcohol will produce ketone, and tertiary alcohol with no reaction. How can we produce carbonyl compound? Oxidation of primary alcohol. The reagent and condition is PCC in CH2Cl2. CH2Cl2 is an inert solvent. So this is primary alcohol because there is only one R attached with carbon and react with PCC in CH2Cl2 to produce aldehyde. So this is aldehyde. So you can see here there is a double bond because we will remove this hydrogen and this hydrogen to replace with double bond. So we look at example CH3 CCH3 2CH2OH react with PCC in CH2Cl2 to produce this structure. So this is aldehyde because there is only one carbon attached with C and there is one double bond because, so we can draw the structure here. Is CH3 see H3 over here. And CH2 OH. So like this, we will remove hydrogen here and hydrogen here to replace with double bond. So this is the answer. So we go to the oxidation of secondary alcohol. So for secondary alcohol, the reagent and condition, we can choose either one, to use KMNO4 H plus heat or K2Cr2O7 H plus heat. So the product will be the same, so we can choose the one. So for the here, this is secondary alcohol because there is 2 R attached with carbon and react with KMNO4 H plus heat to produce ketone. So this is ketone. So we look at example. So for here, you can see here there is double bond because we will remove hydrogen here and hydrogen here to replace with double bond. So we look at example. This is secondary alcohol because there is 2 carbon attached with carbon. And for example, I use K2Cr2O7 H plus heat to produce ketone. So this is ketone because there is 2 carbon here attached with carbon. So this is double bond because we will remove this hydrogen and this hydrogen to replace with double bond. Oxidation of tertiary alcohols. For tertiary alcohol, we use H plus heat with so there is no reaction. So this is 3 tertiary alcohol, because there is 3 R attached with 1 carbon plus KMNO4 react with H plus heat, so there is no reaction. Go to the next topic, chemical properties of carbonyl compounds. So learning outcomes. At the end of this lesson, students should be able to explain the reactive site for addition reaction, explain the chemical properties with reference to addition with KCnH3O+ or KNCnH3O+, reduction to alcohol using LiAlH4 followed by H3O+ or NABH4 in methanol, or H2 in presence of catalyst, condensation with 2,4-dinitrophenylhydrazine 2,4-DNPH as identification test for carbonyl compounds, oxidation with Tollens reagent to differentiate aldehydes from ketones, iodoform test to identify methyl carbonyl group. Reactive site for addition reaction. Negative charge on the carbonyl oxygen atom means that nucleophilic addition is susceptible to acid catalyst, while the positive charge on the carbonyl carbon atom is susceptible to attack by a nucleophile. Addition with KCnH3O+ or NaCnH3O+. The hydrogen cyanide HCN is prepared in situ by the reaction of a mixture of KCN or NaCN with H2SO4. Hydrogen cyanide adds to aldehydes ketones to form cyanohydrins. So here is aldehydes or ketone. React with KCnH3O+. So it will produce cyanohydrin. So we look at example. So it should be double bond here, CH3, CH2. So this is aldehyde. React with KCnH3O, will produce this product. So we only add Cn here and we remove double bond here. Reduction to alcohol. Common reducing agent H. Lithium aluminium hydride LiAlH4 followed by H3O plus. Sodium borohydrate NaBH4 in methanol. H2 with NiPTPD or zinc. Reducing aldehyde. So this is aldehyde sebab ada satu saja R attached pada carbon, react dengan H and produce primary alcohol. You can see here this is primary alcohol because only one R attached with carbon. So reduction of ketone. So this is ketone sebab ada dua R attached dengan satu carbon, react dengan H, produce secondary alcohol because ada dua R di situ yang attached pada carbon, so itu adalah secondary alcohol. So kita tengok pada example. So for the first example we use ethanol, iaitu aldehyde sebab hanya satu CH3 attached pada carbon, react dengan LiAlH4 H3O plus, produce ethanol iaitu primary alcohol. So the second is this aldehyde and this is ketone because ada dua CH3 attached pada satu carbon, react dengan H2 with PT, produce CH3 CH3 OH iaitu propanol, the secondary alcohol. So kita tengok ke slide seterusnya. Sebelum saya lupa, yang ini kita kena buang satu double bond dan gantikan kepada hydrogen. Yang ni pun sama, kita buang satu double bond. Kita buang double bond untuk menghasilkan hydrogen. Condensation with 2,4-DNPH. Brady test. Function to identify the presence of carbonic group. Observation, formation of orange or yellow precipitate. So the general equation, this is ketone because there are 2 R attached dengan carbon, tambah dengan 2,4-DNPH. So this is 1, 2, 3, 4. Ini adalah 1, 2. So ni 2 dan 4. DNPH. So the product akan jadi macam ni sebab oksigen dekat sini dengan 2 hidrogen dekat sini will be removed. So dia akan ambil yang ni terus. So maksudnya yang ni tidak akan berubah. Tambah dengan H2O, tambah dengan H2, H sebab yang kita buang tadi dengan oksigen yang tadi. So ini akan jadi orange atau yellow precipitate. Kita akan tengok example. Kat sini example dia guna ketone juga sebab ada 2 carbon attached dengan satu carbon, tambah dengan 2,4-DNPH. Kalau tak nampak lagi, ni adalah yang pertama, kedua, ketiga dan keempat. So ini adalah 2 dan 4 DNNPH menghasilkan ini, sebab oksigen dekat sini dengan hidrogen dekat sini kita akan hapuskan. So menghasilkan ini. So yang ini sampai N kat sini tidak akan berubah. Kita salin balik je. Dan kita ambil double bond yang dekat O tadi, kita letak kat sini dan kita salin balik ikatan karbon yang tadi, yang ada double bond tadi. So we look at the next slide, oxidation with tolerance reagent. So sebelum tu kita balik sebalik. Maksudnya yang ni akan jadi orange or yellow precipitate juga. So oxidation with tolerance reagent. So function to differentiate aldehydes and ketones. Observation formation of silver mirror. Silver mirror ni adalah AG. So this is silver mirror. So the general equation you can see here, R CH double bond O tambah 2Ag NH3 2 positive charge plus OH minus produce 2Ag. So this is silver mirror. Plus RCOO minus plus 2NH4 plus 2NH3. So kat sini diguna propanol, iaitu aldehyde, itu primary alcohol, plus 2Ag NH3 2 positive plus OH minus. So yang dekat sini ni dia punya silver mirror. Silver mirror kat sini terhasil lah sebab ada Ag. So kita ke iodoform test. Function to identify, this is iodoform test. Function to identify the presence of methyl carbonyl group in carbonyl compound. Observation formation of yellow precipitate. So the general formula, this is the general formula. We'll react with I2 and AOH. So it means yellow precipitate was formed because of CHL3. Kita tengok pada example CH3 CH2 C double bond O CH3 react with I2 and AOH, produce this. Sebelum saya terlupa, untuk yang ni CH3 akan dihapuskan dan digantikan dengan oksigen yang bercas negatif, dan dan akan ada Na positif kat situ plus dengan CHL3. So sama juga dengan example ni, dia akan hapuskan CH3 dan akan tambahkan oksigen bercas negatif dan Na bercas positif. Itu kat sini tambah dengan CHL3. So maksud dia bila ada CHL3, yellow precipitate was formed. So my group has already prepared 3 questions, so you can answer. I think that is all from me. Thank you.
Okey. Okey. So, tu penerangan daripada kawan awak. Dah 6.3 and 6.4. Okay, ada soalan tak nak share? Okay, ada soalan nak share? Okey, kalau tak ada, okey saya rasa sampai sini dulu untuk hari ni. Okey, boleh tengok balik you punya presentation ni nanti, dan hari Isnin, hari Selasa kelas awak. Hari Selasa saya akan record baliklah dalam kelas. Okey. Okey, so saya rasa itu saja. Thank you kelas.